So I usually don't do this, but this is the Chapter 4 review. Since we are virtual learning, I want to give you guys as much help as I can on this Chapter 4 test. So I don't know how long this video is going to be, but feel free to fast forward to get to the problems that you need to go over. Also, I'm sure by the time I'm done with this, there's probably going to be a mistake somewhere in here. So if you find a mistake, let me know, but also I'm going to try to put all the mistakes that I've made and correct those in the description of this video. So let's go ahead and get started. So this first one says, using the diagram, complete the congruency statement for each of the triangles. So this is back in 4.1, and again, all we're doing is we're just saying, making sure we know what order to put this in. So one thing that I started doing is the W I mark as 1, the V is 2, and the U is 3. And I do the same thing down here. So 1, 2, and 3. And then if you look at the other triangle, I do the same thing, but I mark those in the same order. So this has 3 arcs, the W. So that is number 1. So N has to be number 1 because it has 3 arcs. Then 2 was V. It had 2 arcs. So this has to be 2 over here, which is the W. And then 3 was the 1 arc. So the L has to be 3. So then you just put them in order 1, 2, 3. So triangle N, W, L. So you don't have to do it that way, and hopefully you guys are really good at this by now where you don't have to take that much time on it. But just in case, that's a pretty good way to look at it. So we have D, B, C. D was 3 arcs, so we have J, and then C, B, so JCB. And this last one, we have KML. So again, you obviously don't have to mark them. You could say, so that's going to be C, and then M was 1 arc, so that's with A, and then L is 2 marks, that is with B. So CAB for that one. So hopefully those aren't too bad, but that shows up in a lot of things we've done and a lot of things we do on this test. So make sure you're being careful with those. So let's look at the next thing. Use a congruency statement to fill out the corresponding congruent parts. Let me see if I can get them all in there. Here we go. So basically, the way they write this, the order that they write in, the reason you have to write it in a specific order is because there's a lot of things you can tell just by looking at this. So for instance, angle E is congruent to what angle? Well, if E was the first one, it's got to be congruent to the first angle here, so that's H. The segment FE has to be congruent to the segment HG because they're in the same spot. And it doesn't matter what order you put it in. And then it gets a little bit harder. We have EFI, but remember, EFI, that F is always the vertex of your angle. So the F is the one we're looking at. Well, if the F is in the middle over here, it's got to be this middle letter over here, so it's HGI. Then FI is the last 2, so it's got to be GI for this one. Then I have FIE, so I is the middle one, so I is, this one is congruent to the I in this one. So again, it doesn't matter which order you put it in as long as I is in the middle. So HGI, or sorry, I just said I is in the middle. HIG. Then we have IE. Clean this up a little bit. So IE is the first and last. So it's got to be congruent to HI. That should be a segment. So again, so far, not too bad. Then we went on to the third angle theorem. Now remember, the third angle theorem simply says that all 3 angles inside of a triangle have to add up to be 180 degrees. Now there are several different ways you can do these problems, and there's some shortcuts. There's not a lot of shortcuts, but there's a couple different ways you can approach these. I like to just find out what all the angles are if I can in one triangle. So this one has 34, 106. And then I like to find, I say this other angle is Z because we already have an X and Y. And I solve for that one first. So I set that up. 34 plus 106 plus Z is equal to 180, because I have to add up to be 180. I add 34 and 106 to get 140, sorry. 140 plus z is equal to 180. Subtract 140, z is equal to 40 degrees. So that angle is 40 degrees. So now that helps us find angle y. Well, angle y is congruent to that one. Again, if you look up here, angle y is the w, so it's got to be congruent to the w in the other triangle. So y has to be 40 degrees as well. And your x, we have 2x has to be equal to this 106. So 2x equals 106. And again, if you need to check, that is angle I has to be congruent to angle x. They're in the same spot there, just like we did before. Divide both of those by 2. X is equal to 53. Now, one thing you could have done, and this is what I was saying, where it's kind of a little bit of a shortcut, but I don't like to do it. If I know that this angle y is congruent to this angle, if I just call that angle y, then all this work is finding y instead of z. It doesn't make any difference. I just kind of like to take it a step-by-step approach, so it all depends. So let's look at this next one. So obviously we have this angle and this y angle are vertical angles. So again, if you want to call that y and then solve it that way, you can. I personally, again, I like to approach it with, let's just find all the angles in that triangle we can. So you have 85 plus 50 plus z. And again, I just added that z. You could add any letter you wanted. Obviously I didn't want to use x or y because we already used those. To add those together, that's 135 plus z is equal to 180. Subtract 135. Z is equal to 45. So again, if z is equal to 45, that means my y is equal to 45. Then what about my x here? So my x is this angle. And again, if you can't tell that that angle is congruent to this angle up here, you can always check. That's angle D has to be congruent to, oh, there we go. See, angle P. So I made a mistake on that one. Sorry, I was checking my answer key. So I almost made a mistake. I thought angle D was congruent to angle Q. It might look like that, but again, you might want to double check just like we did up here. That's actually congruent to angle P. So x is equal to 50. I'd like to act like I did that on purpose for an example, but I didn't. And the good news is on the answer key that's on Canvas, I did that correctly. And that goes to show, make sure you're taking your time, make sure you are answering these correctly, not going too quickly, making silly mistakes like I almost did. So again, in this one, there's a couple things you can do. Be careful, because this is another one that it's hard to tell what's congruent to what in this one. So I personally, again, I would solve for this angle Z since it's right there. So 36 plus 64 plus Z is equal to 180. If you add those together, you get 100 plus Z is equal to 180. And when you subtract 100, whoops, Z ends up being 80. So this angle is 80 degrees. So now, again, it looks like angle X and J would be congruent because they're both on top, but J is in the middle and X is on the end, so they're not congruent at all. So that's, again, a place you have to make sure you're careful. So to solve for angle K, or sorry, angle Y is this angle K, that's this one, and it corresponds with Y over here, the angle Y, not the variable Y. So that means that one's not too bad. That means Y is 64 because those are congruent. Again, that's what they say here. Then the next one we have this angle I in this triangle, because there's I in both of them, is congruent to, so I in this one with the K and the J, it's congruent to the X in this one, so it's congruent to that X. So that's where we have 2X plus 6 is equal to 80. Subtract 6, we have 2X is equal to 74, I believe. Divide both sides by 2. We end up getting x is equal to 74 divided by 2 is 37. Now make sure you're careful with that. Again, one of the things that I have done wrong is that since this is angle x up here, I solved for that one instead of variable x, so make sure you're being careful with that. But that one, x should be 37. So moving on to the next one. Number 8. Again, same type of deal. I think this one's a little bit easier to, oh, no, it's not. So again, it looks like this angle G would be congruent to this angle G, and it's not. One G is here. That's congruent to angle H. So in the angle with F, this angle is actually congruent to this angle. So make sure you're careful with that. So let's see. So this one, we can't do that where we have all three, like this triangle we had over here, we could easily solve for this one. We don't have that because we have a variable in both triangles. So you have to make sure you're careful with this one. So the way I would do this one, so it says this angle H in this triangle is congruent to angle G in the other one. So G is 65, so this one has to be 65. So now you can use that to solve for y. 45 plus 65 plus y is equal to 180. 45 plus 65 is 110. Plus y is equal to 180. Subtract 110. We end up with y is equal to 70. So that's my y. And what is my x? Well, actually, I could have solved my x first. It would have been a little easier. F is congruent to angle V. So this 45 is congruent to 5x. So 5x is equal to 45. So that means x is equal to 9. So that's the first page of our review. Now we're going on to the next one where it says for 9 through 17, determine if the triangles are congruent. If they are, which theorem or postulate proves that they're congruent? If not, write NEI. Remember that stands for not enough information. NEI, not enough information. So with number 9, we know that this side is congruent to this side is congruent to this side, but we don't know anything else. But we know, remember, this side is in both of them, so that's another side that is congruent. So that means it's congruent to itself. So on the answer key, I put this, but you don't need to include this, but that's because of the reflexive property. Again, you don't need to put that, but I wanted to remind you because it's useful later on in proof. That's the reflexive property. So these triangles, they are congruent by side, side, side. Sorry, there was a little glitch in my smartboard. Moving on to the next one, the big thing with this one is that these lines are parallel. So we know these two lines are congruent, and we also know the same thing with the reflexive property, that JG is congruent to itself, the reflexive property. But then why do they give us that those lines are congruent? Well, again, if you look at those why do they give us that those two lines are parallel? Well, if you look at the two parallel lines, this is the transversal here. So that means this angle and this angle are alternate interior, so they are congruent as well. So if you look at what we did before, JG was congruent with the reflexive. We have alternate interior angles that are congruent, so we have angle, side, angle. So these are congruent by angle, side, angle. So this next one here, we have two sides that are congruent. Then we also know this angle's got to be congruent to that one because of the vertical angle theorem. Again, on the answer key, I put that on there, but you don't necessarily need to put that. They are congruent by side, angle, side. Make sure you realize the order does matter. The angle is in between the two sides. Make sure you remember that. A lot of people get mixed up with, especially angle, angle, side, and angle, side, angle, because it all depends on where that side is. Let's see, number 12. Again, we have vertical angles here. So we have angle, angle, side. Again, notice the side is not in between the angles. So this is not angle, side, angle. The side is not in between those two angles. So they are congruent and is by angle, angle, side. This next one, we have angle, side, and side. Now notice we have, if side angle side would work, that does, I guess I should say, side angle side does mean they're congruent. But this is not side angle side because the angle is not between the two sides. If this angle is congruent, then it would be side angle side, and it would be in the middle, but it's not in the middle. So since the angle is not in between the two sides, remember that would be angle side, don't be an angle side side. So angle side side does not work, so this would be not enough information. And on the next one here, so again, we have parallel lines. So if you're looking at these parallel lines, this is kind of your transversal. It's kind of hard to see, but that means that this angle and this angle are alternate interior. And then we also have the reflective property with that segment PS. It's in both triangles. So we have angle, angle, side. So these are congruent with angle, angle, side. Next one should be pretty easy. We have two angles, and then the reflective property means that line is congruent to itself. Again, since the side is in between the angles, now that's why this one's angle, side, angle, and not angle, angle, side. And the last one, we have angle, angle, angle. I made a mistake on the answer key. I'll correct that. So angle, angle, angle does not work. There is no angle, angle, angle. Not enough information. Make sure you are looking for that. Angle, 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 not enough information. And then, like I said, I made a mistake on that. So make sure you're not going too quickly. Angle, angle, angle is not one of them. And the good news is you guys will have a reason bank, so you'll be able to see all those. So you'll see angle, angle, angle is not listed on there at all. And let's look at this last one. We have side, angle, side. So they are congruent with side, angle, side. Again, the only reason this one works is because the angle is in between those two sides. You have to be careful with that. So the next thing we have is this proof. Now, I will tell you ahead of time, I'm going to zoom out a little bit. I will tell you right away that this proof is harder than the ones you'll have on the test. And it's kind of irritating because, and I should change it, but I'm not going to. This is in the section 4.2 and 4.3 review, and they actually use some things from 4.5 in this one. That's obviously not off limits because 4.5 is on this test still, so don't think that that's not unfair. But I do want to tell you that this is a little bit harder than the other ones that are going to be on the test. So step one, put the givens. So we have angle A is congruent to angle C, and BD bisects AC. That's the given. So let's list this stuff out that we know. So we know A and angle C are congruent to each other. And then we know that BD bisects AC. Well, remember, if you bisect something, that means you cut it perfectly in half, which means we have two congruent sides here. Well, now again, they don't tell us that. They don't tell us they're congruent. They just say that it bisects, so that's going to be our next step. AD is congruent to CD. Doesn't matter what order you put those in. And that is simply the definition of bisect. That's how I knew they were congruent, because if it bisects, that means they've got to be the same. So we've used everything in our given, so that's good. But what else do we know? So far we have an angle and a side. So what else can we tell with this one? So one thing you can tell, and I don't know if this is going to help us or not, but hopefully you realize this angle BD is congruent to itself. Or sorry, not angle. Segment BD, that reflective property. BD is congruent to BD. That's the reflective property. But here's the problem with this one. Now we have angle side side, and I told you you cannot do angle side side. And that's why I think this one's harder than the one that's on the test, because this one's tricky because you almost get to one that works, but it doesn't because we don't have an angle side side. So this is where, again, you have to go one step further on this one. And this is, again, why this one's harder than the one that's on the test, but it is good exercise. They told us in the very beginning angle A and angle C were congruent, so that's awesome. But what else does that mean? Well, if you look at the whole triangle here, not each individual one, you look at the whole triangle ABC, well, if the two angles right here are congruent, that means that the two sides have to be congruent, because if the base angles are congruent, that means this is an isosceles triangle. If you ever have these two base angles as congruent, that means it's isosceles, which means this side has to be congruent to this side. So I have segment AB is congruent to BC. And for the reasons for that, technically, it's the converse of the isosceles triangle theorem. If you just put the isosceles triangle theorem, I'm okay with that if you don't put converse. But again, I'm going to tell you honestly, we do not have that step that I just wrote, this reason. We don't use that at all on the test. So it's good, it's a challenge, it pushes you a little bit, but don't get too worked up over that. So now the last step, we have an angle, we have a side, and a side. Well, this means we can use a couple different things. So first off, we know that triangle ABD is congruent to triangle CBD, so that's good. But we could use side, 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 because we know all three sides. We could use side, angle, side by using this angle here. Either one of them works, doesn't make any difference. Now, I will say there may be another way to do that one, but I don't know what it is. I looked at it for a really long time, and that's all I could think of. But again, I could have missed something little. All right, so let's move on to the next page. CPCTC, remember that stands for corresponding parts of congruent triangles are congruent. And all that means is, if you can prove that the triangles are congruent, that means all the corresponding parts have to also be congruent. So these are the ones like we did before where we're not proving the triangles are congruent. We actually want to prove that the sides are congruent or the angles are congruent. But to get to the angles or the sides, you have to first start with the triangle. So you'll see what we mean with these two proofs down here, 20 and 21. So triangle HEA is congruent to triangle MAN by, we have angle, angle, side. So angle, angle, side. What other parts of the triangle are congruent? Well, when they say what other parts, we already know that this is congruent to this one. We already know that this line is congruent to this line, and this angle is congruent to this angle because that's given to us. They show us that in the picture. But what else can we tell? Well, we can also tell that angle HY, or sorry, segment HY is congruent to segment MN. We know that segment EY, I guess I should mark that. We know that EY is congruent to AN. And lastly, I know that angle H is congruent to angle M. And again, the reason is because if we know the triangles are congruent, which is what we did here, that means all the other corresponding parts have to be congruent as well. So let's look at these proofs. Now again, these proofs are definitely, in my opinion, they're a lot easier than the last one. And again, the last one we did wasn't that hard. It was just that one step that I think is difficult. So for these, step one, I'm going to probably end up using too much room for this, but that's okay. AB is parallel to BC. Angle B is congruent to angle D. That's our given. Now again, notice we are proving that the sides are congruent, not the triangles. So I'm trying to prove that BC and DA are congruent. If you're going to mark those down, try to put little question marks so you know that you don't know that yet. That's what we're trying to find out. I don't like to write them down. But again, to prove that those two sides are congruent, we're going to have to first prove that the triangles are congruent. Once we know the triangles are congruent, we know that these two sides that correspond also have to be congruent. So that's our main objective. First, let's prove the triangles are congruent. So AB is congruent, or sorry, is parallel to DC. So let's mark those as parallel. And B and D are congruent. So if they ever tell you that they have parallel lines in the given, make sure you realize that means something to us. So again, if you need to, think of it this way. We have this line and this line are parallel, and we have this transversal that goes through them. Well, that means that this angle and this angle are alternate interiors, so they have to be congruent. So that's what we're looking for. And it doesn't always work this way, but a lot of times it is alternate interior that ends up happening. So what else do we have? D. So that means angle A is congruent to angle C, or sorry. Let's do it a little bit more specifically. Let's do angle BAC congruent to angle DCA. Now again, if you just put angle A and angle C, that's not really specific because I don't know which one it is. So make sure you're being careful with that one. So now the reasoning for that. We already said that it's the alternate interior angle theorem. Now technically, if you want to be really fancy and you want to do what we did before, I wanted you guys to say lines are parallel if and only if alternate interior angles are congruent. If you still do that, that's awesome, but honestly, if you just put alternate interior angles, I'm okay with that. So we have two angles, but no sides. And again, remember, we need three things for all these. If it's side, 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 angle, side, angle, angle, side, or angle, side, angle, we need three things for all of those. Even if it's hypotenuse, leg, we need to know it's a right triangle, and then we know the hypotenuse and the leg. So all those, we need three things. Again, so far we only have two, but I know AC is congruent to AC because it's in both triangles. So now we have triangle ABC is congruent to triangle CDA. And I know that because of angle, angle, side. Angle, angle, side. So this is where a lot of people miss this because they finish. They say, okay, cool, I'm done. I've proved those triangles are congruent. No, we're not trying to get the triangles are congruent. We're trying to prove that those two sides are congruent, but it's not any harder. It takes one more step. I know that BC is congruent to DA. And it's all because C, P, C, T, C, corresponding parts of congruent triangles are congruent. And you will have that on your bank of reasons as well. So same type of thing with this one. Again, we're not proving the triangles are congruent. That's not the objective, but we do have to prove that they're congruent to be able to see that angle X and angle E are congruent. So angle F is congruent to angle Y. Actually, let's write that out for my given. Angle F congruent to angle Y. And G is the midpoint of FY. So that is all given. So let's make sure we mark that. F and Y are congruent. And they say G is the midpoint. So G is the midpoint of that line, which means if it's the midpoint, that means FG and GY are congruent. FG is congruent to GY. And I know that because, again, it says it's the midpoint. That's the definition of midpoint. Then I know that this angle and this angle are congruent to each other because they're vertical angles. So we have angle FGE is congruent to angle YGX, because the vertical angle theorem. So that means my next step, I know that the triangle FGE is congruent to the triangle YGX, and I know that because of angle side angle. That side is in between my two angles. But again, that's not what we're trying to do. We're trying to prove that angle X and angle E are congruent, so it takes one more step. Angle X, angle E are congruent. Because CP, CTC, corresponding parts of congruent triangles, are congruent. Then this last thing, I didn't really talk about this very much, but it's very self-explanatory, or I guess I should say it isn't difficult. You should be able to either Google it, or once you see it, you should know. Equilateral triangles means that every side is the same. Every side is congruent. Also, every angle is congruent, for what it's worth. But we're more focused on the sides. Isosceles means two sides are congruent. Again, obviously, also, ironically, two angles are congruent. And the last one, scalene. No sides are congruent, or angles for that matter. But really, we're focusing on the sides for these three. We went over equilateral and isosceles. We didn't really talk about scalene. All right. So the last page. Again, make sure you write equilateral means all sides and angles are congruent. And isosceles means two sides, the legs are congruent, and the base angles are congruent. So, for instance, with 23, this is isosceles because these two sides are congruent, which means the base has to be congruent to the other base angle. We have 72 plus 72 plus x is equal to 180. There's other ways to do that a little bit, but that's the easiest way. So it's 144 plus x is equal to 180. Subtract 144. X is equal to 36. Number 24, this one's easy. Since it's isosceles, the base angles are congruent, so it's just got to be 65. That's what the other base angle is. In this one, it's equilateral, so all the angles are congruent, which means that's got to be equal to 60 because the other angle is 60. Now remember, with an equilateral triangle, since all the angles are congruent, every angle has to be 60. That's the only possibility. Again, they have to all add up to be 180. So if they're all x, 3 times x has to be 180. Whoops. And so it's got to be 60. I think I said that in one of my other lessons with that. So if you want to check, I think that's 4.5. Then looking at 26, so again, now we know this one's x, so we have x plus 42 is equal to 180. At boards, there we go. We have 2x plus 42 is equal to 180. Subtract 42. So 180 minus 42 is 138. Then divide both sides by 2. We end up getting x is equal to 69 for that one. Let's zoom in here, make this a little bit bigger. Number 27, again, we know the base angles are congruent, which means I know the sides are congruent. So 12 is equal to 2x minus 6. So add 6. 18 is equal to 2x, divide by 2, we have 9 is equal to x. Over here, all the angles are congruent, which means all the sides are congruent, so it's equilateral, which means x has to be 11. So all the sides have to be congruent to each other. This one, a couple different ways to do this. First off, the easiest way, again, it's an equilateral triangle, so all the angles have to be 60. So x has to be 60. You don't even have to really do any work. But if you want to, if this is a linear pair, I know this has to be 60, so it adds up to be 180, which means x is equal to 60 as well. Again, either way is fine. So this one, you do have to see that it's a linear pair. So 113 plus whatever this angle is. You can call it question mark or z or whatever you want to call it. Or you don't have to call it anything, I guess I should say. So that ends up being 67 degrees. So if this is 67 and this one's 67, now we have 67 plus 67 plus x is equal to 180. That's 134 plus x is equal to 180. We subtract 134. X is equal to 46. And the last part of this goes fairly quickly. Are the following pairs of triangles congruent by hypotenuse leg? Now again, we need three things in all the congruencies we've learned so far. Again, I said this before, but side, 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 angle, side, angle, side, angle, 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 side. All four of those need three things. Same thing with hypotenuse leg. We need to know that it's a right triangle, and then we need to know the hypotenuse are congruent to each other and the legs are congruent to each other. So 431, we know the right triangles because we have these right triangle symbols. This is the hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle, and then the leg is the reflexive property. So that reflexive property means it's congruent to itself. So now we have, yes, hypotenuse leg. I think you can just put yes on that one. I think that's what I did. And again, on the answer key, I pointed out that's reflexive, but you don't actually need to do that. So this one, if you look at this one, we don't know that they're right triangles. So you can only use hypotenuse leg if it's a right triangle, and we can't tell that. So the answer is no, we can't tell by hypotenuse leg. But we could tell by, well, even that would be angle, side, side, so we have no idea if they're congruent or not. But yeah, no, they're not right triangles, so we have no idea. Then these next two, they are right triangles. We have the hypotenuse and one of the legs. So this one's yes, you can tell. And this one, again, we have vertical angles here. So again, we don't have any right triangles marked on here. So technically, this would be side, angle, side. So I could tell you that they're congruent. But that's not what they're asking. They're asking if you can tell by hypotenuse leg. Now, this number 35 is actually a really complicated one because a lot of you guys are going to say that you can't tell because they're not a right triangle. But we have that property that we learned with isosceles triangles where if we have an angle bisector that goes, it bisects the the vertex angle. That's what it was called. Whatever that top angle is that's different than the base angles, if you have a bisector, it cuts that straight in half, it's an angle bisector, then that goes down here, and not only does it bisect the base, but it also is a perpendicular line. So that's perpendicular, then we know the hypotenuse and the leg is reflexive. So that one's, again, I don't think you'll have one that's that hard on the test, but technically that is correct. 36, they're right triangles. Again, we have a hypotenuse. The leg is reflexive. Technically, they didn't label the other one as the right triangle, but obviously, if this is 90 degrees, this one also has to be 90 degrees. That one's yes by hypotenuse leg. Guess this should be yes too, sorry. And the last two, So this one's another one that I don't think you'll have this on your test, but this one's another one that's a little bit tricky. And the fact that the reason it's tricky is because you can use the inverse of what we just talked about for 35. The inverse says that if this isosceles triangle, so it's isosceles because these sides are the same, if it cuts this base angle into two congruent segments, that means it bisects that, which means it's got to be a right triangle. And technically, these angles are the same. But that means they are congruent by hypotenuse leg. But again, that's a little bit of a stretch. And actually, when I'm talking about it, I don't remember if we've gone over that or not. But it doesn't matter. Like I said, I don't think you'll have one like that on the test. And this last one, again, we know the hypotenuse, the leg is reflexive. So yes, by hypotenuse leg. I guess this one's yes as well. So the last thing I'm going to do, because that's the end of this, and I was going to do this and forgot about it, but the proof we did up here, where is it at? Wasn't that one? Where was it? There was one proof that I thought we did. Maybe that was something different. Yes, number 21. So this proof, the way that I showed you is the easiest way to do it. But if you thought about it, there's actually one other thing you can tell. If f is congruent to y, so just real quick, this is the given stuff, blah, 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 this stuff, and it's given. Step 2, you could say that, okay, since f and y are congruent, that actually makes this xy and this fe parallel to each other. Because those alternate interior angles, if they're congruent, that means the lines have to be parallel. So you could say FE is parallel to XY. And I know that because if the lines are parallel, if and only if alternate interior angles are congruent. So why does that help us? Well, that helps us because if we know those two lines are congruent, then we have to know these angles are congruent. So that means angle E is congruent to angle X. Same thing, alternate interior angles. And then we have this part, G is the midpoint, so, sorry, that means FG and GY are congruent. Definition of midpoint. So that means that the triangles are congruent. Triangle SEG congruent to triangle YXG by angle side. Hold on, sorry, got carried away. So again, remember what you're trying to prove. I'm just trying to prove that X is congruent to E, and I did that right here. I just proved X and E are congruent. I didn't actually need these last steps right here. So that's a good example. Again, make sure you know what you're trying to prove, because I got carried away where I was going to prove the triangles were congruent and then use CPCTC. But we could have stopped right here because, well, if they're parallel lines, then these two angles have to be congruent because they're, again, another pair of alternate interior angles. That's funny because I was like, I thought it was shorter this way. Okay, it is shorter. You just have to make sure you're aware of what you're trying to prove. So if you have any questions, make sure you let me know. Again, please watch this again, watch it over, try to do some problems on your own, and then go back and watch them again to see if you knew how to do them. And again, obviously for a lot of these, there's very many other ways to do these. So again, if you have any questions, please let me know.